Hey Algebros, we are going to be continuing to convert quadratic equations. So just in case you forgot, this is standard form, vertex form, and factored form. Alright, so from standard form, we can get to factored and vertex form. So let's talk about factored form first. We're going to factor a GCF out. So 570 and 225 are all divisible by 5, so we're going to divide that 5 out, leaving us with x squared minus 14x plus 45. And don't forget, we have that 5 that we took out. All right, so when we get to factored form over here, we have our a times c, which would be 45. And our b term is negative 14. So we're looking for factors of 45 that will add to 14. So if we list those factors, it's 1 in 45. 2 doesn't go into 45, but 3 does. 3 goes into 45 15 times. 4 does not, 5 does, 9 times, 6 does not, 7 does not, and we're back to 9. So if we look at these, which ones would add to 14? 1 plus 45 would be 46. 3 plus 15 would be 18. 5 plus 9 would be 14. So those are the factors we need. Now notice that they multiply to a positive value but add to a negative. So that means both terms are going to be negative, because when we multiply two negatives together, it gives us a positive value. When we add two negatives together, it gives us a negative value. So our two factors are going to be x minus 5 times x minus 9. And don't forget about the 5 we took out at the beginning. Write our function notation, and that would be that equation in factored form. Vertex form is a little tricky. So we've already taken that 5 out, so we're going to just leave that 5 out for now. Oops. Okay. I said I was going to leave the 5 out, and then I wrote it. Set that equal to 0. So we're going to subtract 45. Remember, we have to complete the square, so we have x squared minus 14x equals negative 45. So our b term is negative 14. B divided by 2 would be negative 7. And b divided by 2 squared would be positive 49. So 49 is what we're going to add to both sides. So when we add that 49 to both sides, the left side is going to factor into a perfect square trinomial. And adding 49 to a negative 45 is going to give us a positive 4. And so now to get it back into vertex form, we're going to subtract 4 from both sides, leaving us with x minus 7 squared minus 4 equals 0. But remember, we took that 5 out from the get-go, so we have to multiply this by 5. And we get f of x equals 5 times x minus 7 squared minus 20. All right, let's take a look at this next one. I personally do not like decimals. I like fractions, so I'm going to change this to a fraction. If you want to use decimals, by all means use decimals, but fractions are way easier to work with, I promise. So 0.25 would be a fourth. 25 cents is a fourth of a dollar. It takes 4 quarters to make a dollar. So to get this into standard form, I'm going to multiply it out. And x times x is x squared. X times 6 would be 6x. Negative 4 times x would be negative 4x. And negative 4 times 6 would be negative 24. I still have that negative 1/4 hanging out. I'm going to combine my like terms. 6x minus 4x would be a positive 2x, and we still have that negative 24. And now I'm going to distribute that 1/4, and once I distribute that, it's going to be in standard form, so I'm going to go ahead and write that distribution over here. It's negative 1/4 x squared minus 1/2 x minus plus 6. Negative and a positive, or negative and a negative would make a positive. All right, so now we are in standard form. Cool beans. Now vertex form is the beast, so we're going to go ahead and take care of that a value. If we multiply everything by a negative 4, we're going to get rid of that 1/4 a value. So I'm going to multiply this by negative 1/4, or by negative 4, sorry. And when I do that, I get positive x squared plus 2x minus 24. So as you can see, we're just redoing the factoring, or redoing the multiplication, if you will, from the factoring one. Okay, so now we can complete the square from this. So I have x squared plus 2x minus 24, set that equal to 0. So go through the completing the square step, add 24 to both sides, we get x squared plus 2x equals positive 24. My b value is 2, so I'm going to take b divided by 2, which would be 1, and b divided by 2 squared, which would also be 1. Then we'll be adding 1 to both sides. So when I add 1 to the left side, it's going to create a perfect square trinomial, so it's going to factor nice and pretty, just like that. And 24 plus 1 would be 25. Okay, and now I'm going to bring that 25 back over, so it's all buddy-buddy with the parentheses. So subtract 25, x plus 1 squared minus 25 equals 0. But remember, we multiplied by 4, so now we have to divide by 4, and multiplying by 1/4 is the same as dividing by 1, or dividing by 4. So we're going to multiply this whole thing by negative 1/4 because we want to undo what we did. So I have a negative 1/4 x plus 1 squared minus plus, negative and a negative 25/4, and that puts us in vertex form. We can go check these on Desmos if you want. All right, our last one, we start in standard form, and we need to get to factored in vertex. So I find factored form easier than vertex form, so I'm going to start with that. I'm going to take out my common factor, which would be negative 3, so I'm going to divide each term by negative 3. And when I do that, I'm left with x squared minus 12x plus 27. All right, so over here I have a negative 3 times x squared minus 12x plus 27. And I go to factor, I have positive 27 up here and negative 12 down here. I want the factors of 27 that will add to 12. So the factors of 27 are 1 and 27. 2 doesn't go into 27, but 3 does. And 3 goes into it 9 times. 4 does not go into 27. 6 does not go into, or 5 does not go into 27. 6 does not go into 27. 7 does not go into 27. And 8 does not go into 27. And we're back to 9. 1 plus 27 would be 28. 3 plus 9 would be 12. So those are the factors we're looking for. And since they multiply to a positive, but add to a negative, both values are going to be negative. So my trinomial will factor into x minus 3 times x minus 9. And don't forget about that negative 3 that we took out. Slap on some function notation, and we have factored form. All right, vertex form. We already took out that leading coefficient, so we can just get started with what we have left. we're going to take that 27 over, and we have x squared minus 12x equals negative 27. B equals negative 12. B divided by 2 would be negative 6. And B divided by 2 squared would be a positive 36. So 36 is what we're going to add to both sides. When I add that 36 to the left side, it makes a perfect square trinomial. So it's going to factor into a perfect square binomial. And when I take negative 27 plus 36, that's going to be a positive 9. So I'm going to subtract that 9 back over. And I have x minus 6 squared minus 9. But don't forget, we took that negative 3 out. So I need to bring that negative 3 back in by multiplying all of that by negative 3. So we have negative 3x minus 6 squared plus 27 function notation, and there we go. We are in vertex form. All right, if you made it to the end of this video, you can put like the laughing emoji in or something like that, because today's lesson are these 5 exact equations. So if you took notes, or if you're just now discovering this and want to go back and take notes, all of the answers to today's assignment have been done in these 2 videos. So thank you for watching. Thank you for doing what you're supposed to be doing. I really appreciate it. So now you're going to go work on the quizzes, and when we get done with that, you can work on Mathia. But drop a laughing emoji or a smiling emoji or something of that nature in the chat so I know you got here, and I know to expect you to do well on today's quizzes assignment. Thank you. Have a great day.